This is Mr. Jarvis, and I am in the engineering lab, and I want to talk to you today about activity 8.2 CAMs, or parametric modeling, producing CAMs. It's a whole process. It really is kind of a neat process. If you look on Classroom, and that's where I am now, under Classroom, under activity 8.2 CAMs, right? You're going to find three different resources. The first one is the one that really is important, the one we're going to kind of be following today. This is our CAM types using parametric modeling, dimensioning. So we have a circle CAM, we have an offset circle CAM, we have a polygon, a pear is what they term it as, a snail CAM, and a hard CAM. Now, as you can see, they have D values, or D dimension values, and the D0 value, which is called the nominal diameter. That's what really everything is based on, that D0 value, So we're going to create three of those CAMs, or you need to create three of those CAMs. In the end, you're going to take those three CAMs, you're going to put them on a page that looks like this. So notice I did open my PA template, I copied it off. And then I made the three parts parametrically, and I put out my title block. I'm going to print it out, and I'm going to put it in my notebook. Now, these CAMs can be used in your AutonomoBox project. You're probably going to have to use some of them, so it really has to depend on which ones you want to use. Today, for demonstration purposes, I'm going to just use a simple offset CAM, which is actually the one that I used. I used two of them in my Seesaw, the Bear Seesaw prototype drawing that I did. So that's the ones that I use. So we're going to jump right into Onshape. Let's see. Onshape. So, there we go. And as we've done many times before, we're going to go to PA template, open our PA template, right? And we are going to call it activity 8.2 parametric modeling, right? Parametric CAMs. Oops, sorry about that. Now, this is our drawing file, or our PA template as we call it. But in order to do the CAMs, I'm going to have to build some parts. So I have to go and add a part studio. Boom, create it. I'm going to start with a simple offset CAM. It's just a circle with a hole through it, but the hole is a little bit lower than the actual center of the circle. As you know, when I'm doing a part, I always start with a sketch on the front for the most part, and then I'll go back and turn off the visibility of all of those. Hit front view. I like to look at it straight on, and I'm just going to start with a circle. Do I start in the origin? Almost every single time. Almost every single time. Now, over here on the right side of your screen, you know that we have a lot of different characteristics or resources over here, including a variable table. So I want you to click on that variable table, and you'll see it come right up. Let me move myself over here. That's what it's going to look like. Now, variables are things that we can drive the dimensions with. So we can substitute a variable for a dimension, and it will tell us how big it's going to be proportionally. The goal is, if you do it parametrically, you should be able to make the CAM one size and then make it twice the size without it losing all of its features, right? It's not going to look distorted. It's going to blend right in nicely, which is really the purpose of doing parametric modeling. So just to start with, I'm going to call this my D0 value, or some people would just put D0. Some people, I know on the template, it says nominal value. And when you write down the variable name, nominal diameter, DIA, let's say nominal diameter. I'm going to start with a diameter measurement. Don't worry that it's going to look like it's not spelled right and all that other stuff because I didn't put any spaces there. It's going to be a length measurement, and we are going to give it a value of 2. So if we have a value of 2 for the diameter, when I come over here on my screen and I go to dimension, the diameter of this, I'm going to say the diameter is going to be not 2. I'm going to say n. Notice when I put n in, because it says nominal diameter. Click and hit enter. And it will make it 2, but see the fx, that means it's a substitute function. So I placed a function in there so that when I change my variable over here, the diameter is going to change over here. Now, if you look at the drawing we're working with, that's this one right here, and we're doing this center one. So I have my D0 value set for 2, and then I have to do a hole here. This is where the axle goes through. Now, one thing about the axle never changes. It's always going to be a 1/4 inch, and it's always going to be a through hole. It does change where it's located on the cam, but that's not going to change. It says it wants a dimension value 1/4 down is where the hole for the axle is going to be. So we're going to just draw if I zoom in there, come down, notice I try to draw that straight down. Now, if I put it over here and it's not straight down, I could once again use my constraints and say I want it to be vertically aligned, and I'll just pick the origin and I'll pick this, and they become vertically aligned. So there are ways to make sure it's straight. I've had students draw lines from there down and then dimension, doesn't matter. Vertically aligned is fine. Now, the dimension for the hole will never change. It's always going to be a 1/4 inch. So I'm going to put in 0.25. Now, the reason I don't give it a variable or a function, if my cam gets huge, let's say I make it 8 inches in diameter, it doesn't matter. My hole for my axle is still going to be 0.25. So that's not going to change. So what will change is this distance right here. The distance from here to here is what's termed as the offset distance. That's why they call it a circle, offset circle cam. So we're going to over here, I'm going to type in offset. You can put in distance if you like, offset distance. It's going to be a length. Now, instead of putting 2 down or 1/4 inch or whatever, if I want that offset distance to be 1/4 the diameter, that's going to be, so I'm going to say here, I'm going to say nominal diameter divided by 4. Right? That's going to give me 0.5. Now watch, if I come here and I edit my dimension, if I said offset, notice it gives me the offset. I hit O, put that in there, and it's going to make it 0.5. It's automatically 0.5. Now, the interesting thing about a circle cam, think about this. As this goes around and the follower, the one that goes up and down, how far is it going to move up and down as it circles around? Well, the distance is going to be the distance from the center of the cam to the center of the offset. So if I want to give a higher lift, more than 0.5 inches, I have to create a greater distance of more than 0.5. Kind of interesting. So I could come over and make it bigger if I needed to. For now, notice it's a function, 0.5 function. And this is my circle cam, offset circle cam. I only have 2 variables right now. I have the diameter, I have the distance down. And remember, the hole is always going to be the same. So I can finish my sketch. I can extrude. I believe most of these, if not all of these, are going to be a 1/4 inch. Now, 1/4 inch, that's how thick the cam is going to be. That doesn't change either. Even if I made my cam, 26 inches in diameter, I still only wanted a 1/4 inch thick, and I still want the axle to be a 1/4 inch. So in this case, I'm going to give it just a measurement of 0.25. Pick what I want to do. take a look at it. That looks pretty good. So when I'm down here, as I've reminded you many times, good idea to rename it. In this current, I'm just going to call it offset cam. Remember, this is what comes up in your bill of materials. Offset cam. Boom. And the other thing you can do, I got too many things in the way, but it's not a bad idea to rename this down at the bottom, your little tabs, offset cam. Boom. If you want to, you're welcome to change the appearance. Change it to yellow or whatever you want to change it to. Now, what's so important about creating this parametrically? Well, this is where it goes. This is how interesting it can be done. Let's say I decided it's too big. The cam is too big. I want to change this. When I come over here in my variables, if I change it to 1, it should change proportionally. Notice it went to 1. This one went to 0.25, but the whole stays 0.25. Better yet, if I said I want my diameter to be 10, it comes out, and it's a 10-inch diameter cam. The 1/4-inch hole is still a 1/4 inch. It's still extruded back a depth of 0.25, but the distance, the offset distance, is now 2.5 inches. So it can get larger or smaller proportionally simply by using these parametrics, parametric modeling, and using variables. So when I finish my first one, which is pretty easy, a good suggestion would be to do a duplicate so that I can start on my second one. Now, the second one is going to be, let's say I'll do the polygon cam. So maybe right off the bat, I'm just going to call it my polycam. I'm going to rename it so I don't get confused. Polygon cam. Boom. Done. Now, my variables are still here. See them? If I pull them up, because I copied it, I have my nominal value variable right there. So what I just need to do is really, I have to go back and I could either delete the extrusion, which will leave my sketch, and then I get back into my sketch. Aha! Look at that. I accidentally left it at 10 inches when it was really supposed to be 2. So I'm going to go back and say 2. 10. Now it's the appropriate size. So this is where it used to be, or the original offset cam. But we're converting this by looking at it from the front to a polygon, which means I'm going to create a polygon. I come in. It automatically wants to make a polygon. So what I typically do is I'll make a polygon, and as soon as you click, then it asks you how many sides to your polygon. And if you look at the template, it looks like 6 sides. Now, I know it's annoying, but look what happened to my polygon. It's kind of slightly tilted. If you want to straighten that out, you can just use your constraints and say, oh, I want it to be horizontal on the top. And it will straighten it right out nicely. Okay. Now I have my polygon in shape. I need to get rid of my circle. So I'm going to select the circle. I'm still in variables there. I'm going to select the circle and I'm going to delete it. Now, the 1/4 inch, see this where it says a 1/4 inch diameter hole for the axle? That's not going to change on any one of the cams. What is going to change is the location of that cam. So I'm just going to delete this dimension. And because I don't have a dimension there, I can just grab it and move it up, put it right in the middle. That's where it's supposed to be anyway. So the only variable I'm going to have on here is how many sides, obviously. But the dimension here is the variable from there to there. And that is going to be half of the D2 value. So I'm going to look over here. Now I could give it another name. So I'm going to call this poly height. You can call it anything you want, really. Poly height. this dimension is going to be the nominal diameter divided by 2. And that's going to be 1 inch. So I've set my variable here. Now I'm going to add my variable to my drawing simply by putting in P. It's going to come up with polygon height 1. Boom. So now it's going to get proportionally larger or smaller as I change this D0. By the way, I should probably put in my D0 values. This is my D0 value. So now I'm just going to say N2, enter. It didn't like it. I wonder, let me hit undo for a minute. Sometimes we get those red ones. I think I know what happened. I should have, see this right here? I need to take that out prior to doing my diameter. So I'm going to put my diameter in first. And that's going to be N2. Well, now, when I go here to there, that's going to be 1, obviously, based on the diameter. But I'm going to put it into my poly height right there. And poly height is 1. Oh, apparently my poly height is 0. What did I put in? Oh, so it should have been nominal diameter divided by 2. For some reason it lost the constraint. Now the truth is, I didn't really need this one. Because if my radius, or the height from the top to the bottom, it's inscribe type of polygon, so the diameter of this inscribe circle is going to be 2. If my height, polygon height, is 1, it's going to be 2 anyway. So I'm just going to say poly. Now somebody asked, can you actually extrude something that's red? And the answer is definitely. You can always extrude something that is, even though the sketch is red, you can still extrude it. 0.25 doesn't really matter. There's something interfering, and that's telling you that there's something interfering. I'm going to rename that one. We're going to call it polygon. All caps, of course. Camp. Now that sketch is red. Am I concerned? Not really, as long as my part comes out fine. Now, what you should be able to do, and I'm curious if this will work, if I change my nominal diameter to 8, right? Did it get larger or smaller? Oh, the numbers changed. I'm curious if that got, it should have gotten larger or smaller. If I change this, let's say I change it to 80. Oh, the variables got bigger, but I know why. Well, there you go. There's the reasoning for it. I'll go back to 2 again. Now, see how these variables are changing automatically? Well, guess what? Because I have that red in my sketch, I'm getting all sorts of problems. So I'm just going to delete the diameter there and see what happens now. If I make that 10, that's what I should see. The polygon is now 10 inches from here to here. That means it's 20 inches from top to bottom. And the hole in the middle is still 1/4 inch. That's what's supposed to happen. It's parametrically linked. I'm going back. So once again, we're going to change the color here a little bit. Maybe green. All right. Now we got 2. We got an offset cam, which is still too big. That's supposed to be 2. And we got the Now, you still need to do a pair cam, and you have to have a minimum of 3. I mean, if you want to try a snail cam or maybe try a heart cam if you wish, that's fine. You can try. All you got to do is 3. You're going to take your PA template. You're going to put them on your PA template, much like you see. I gave you an example of what it would look like. Now, it doesn't have to be perfect, but I wanted to see the front view and isometric, and then you label it. Front view, isometric label, front view, isometric labeled. Fill out your title block. When it's done, you're going to print them out and 3-hole punch them and put them in your notebook. That is the assignment for today. So build your cams and see, once you've built them, whether or not you can make them larger or smaller based on those variables. That's what parametric is all about, is connecting or creating functions to connect dimensions so that the object will get larger or smaller depending on your design. By the way, in this one, I'd probably even add one more, maybe a radius, or fillet. That's what it is. Fillet, radius. I'll do a regular length again. I'm going to base it on the nominal dimension, 2 inches. So I want my fillet to be pretty small. And if I divide by 10, that's 0.2. If I divide by 20, that's 0.1. So I'm going to divide by 20. So when I go to do my fillets, and I'm thinking about filleting this edge right here, I'm going to come in here and I'm going to say, just like we did with our other dimensions, it's going to be a fillet, boom, radius, and it comes up 0.1. So now I'm going to do that to all of them. This will make my follower, that's what's going to go around the edge of it. Some people call it a lifter. It's going to make it go nice and smooth around that edge. See that? Now, what's interesting is, as I make this bigger, if I make this 10 inches, 2 things have changed. Obviously, it got 10 inches bigger, right? But notice the fillets, it proportionally got bigger. Now they're 0.5. But the hole in the middle is still 0.25. And the depth of extrusion is still 0.25. You can play around with that a little bit too. So, once again, you're going to build your cams parametrically, and then you're going to lay them out on your PA template, much like you see on the sheet here. Once you get that done, boom, you're done. By the way, you're building these on a purpose, for a purpose, so that you can do your Autonomobox project and you'll have your